In this video, we're going to discuss heat and temperature and their effect on equilibrium and how they're related to Le Chatelier's principle. Consider the equilibrium that we were studying in a previous video. The link is in the description. In this case, let's assume that this is an exothermic reaction, one in which the surroundings will heat up as the reaction takes place. Some have the custom of writing heat as a product in this reaction, so we might treat it as a product for the sake of talking about Le Chatelier's principle. As we discussed in a previous video, adding products means that now we would have an increasing amount of reactants that would form as we return to equilibrium, and the amount of products would decrease. This might get the right answer, but it's chemically incorrect. If you look at the expression for Q, we see that there's no place for heat in either the reactants or the products, and so therefore Q cannot be changed as a result of adding heat. Instead, we'll have to examine why temperature change affects equilibrium. Equilibrium constants are temperature dependent. If we look at the Van 't Hoff equation, we see that the natural log of the equilibrium constant K is equal to the negative delta H of reaction divided by the molar gas constant R times 1 over T plus delta S naught of reaction over R. Let's examine what this looks like for exothermic reactions. For an exothermic reaction where delta H is negative, the first term in the expression for ln K is positive. 1 over T is always positive, which means that at any temperature, that entire first term will always be positive. But what does it mean to increase the temperature? If we increase the temperature, higher T, that means we have a smaller 1 over T. And a smaller 1 over T means a smaller natural log of the equilibrium constant K, or a smaller K. So if we started at equilibrium, where Q was equal to K, well, now we have a new K, and that new K is smaller than the K we started with. So Q is now greater than K, and the reaction will be non-spontaneous, and more reactants will form over time. And that's why if you increase the temperature of an equilibrium that's exothermic, then more reactants will form. But if the reaction's endothermic and at equilibrium, increasing the temperature will lead to more products.